All right, guys, so the next lesson we're going to look at are key features of polynomials. Now, unlike most of my videos, I already have this tree diagram filled in because we've essentially already looked at it. I just want to quickly hit some of these things, go back and refresh them. The reason I say we've already learned them is because the key features of polynomials are just like functions. However, if you notice, polynomials do not have an equal sign. Remember, domain is all x values, range is all y values. Max are the high points, min are the low points. Now, one new thing that polynomials talk about are your absolute min and your absolute max. Okay, so in this picture, okay, I have, just a function drawn, or excuse me, a polynomial drawn, and the purple dots represent maxes because they're peaks, right? They're high spots. In the valleys or the low spots, I have them marked with the green dot. Absolute means extreme, okay? So when you think of extreme, it's either the worst or the best, or in the case of polynomials, the lowest or the highest, okay? And you can see I have absolute highlighted there in blue, and so I circled around the absolute min and the absolute max. The reason this left point is the absolute min is because it's the lowest of the two identified mins. Same reason for the absolute max. It's the highest of the three peaks or hills, okay? We have roots or solutions or root zeros to polynomials as well. Remember, a root or zero deals with one function. It's where the graphs touch, meet, or intersect the x-axis. If you want to look at it through a table, say your graph is crazy, your answer choices have x equals values. You just pull up your table, type that particular x value in, your y value should be 0, right? That's going to eliminate you having to zoom out and change the window on your graphs. Multiplicity we talked about a little bit with the roots and solutions. Again, I want to hit on it very quickly. Multiplicity is when the polynomial has a multiple root or the same root multiple times. If it is odd, the graph will go through the x-axis. Okay, so 1, 3, 5, 7, any odd amount, the graph is going to go through. If it is even, the graph is going to touch, or I like to think about it bouncing, but it's not going to go through it. Okay, so the yellow dots represent multiplicities that are odd. The orange dot represents a multiplicity that is even, right, because it touches and bounces. In behavior, I think we were, starting to get a little bit better with it. We just haven't seen it in a while, so I'm going to take just a little bit more time here. In behavior is what y value does the graph go to as x goes to both positive and negative infinity. Remember the way it's read. As x goes to negative infinity, y goes to blank. All right. And then the last one is x goes to positive infinity, y goes to blank. Okay, so you would just fill it in. More times than not, it's going to be positive or negative infinity. Okay. I'm going to do 4 examples really quick. If you look here, I already have the notation wrote out. X goes to positive infinity. Now, really quick, if x goes to positive infinity, I'm going to label this as my r, okay? And then as x goes to negative infinity, this is my leftmost x, okay? So my left arrow is negative infinity. My right arrow is positive infinity. All right. And once you do this, like what y value? is it going to positive infinity or negative infinity? If it's pointing up, it's positive infinity. So this graph on the left is x goes to positive infinity, y also goes to positive infinity. As x goes to negative infinity, so my left, the arrow is pointing down to negative infinity. All right, over here on the right, if you want to pause your video, you can. Again, left, right, negative infinity is left, positive infinity is right. This is talking about x values. Now we need the y value. So x goes to positive infinity. The arrow right here is pointing up, so it's pointing to positive infinity. As x goes to negative infinity, so my left arrow, y, goes to, it's pointing up, so it's positive infinity. Okay. Again, over here, label my left, label my right. Because this is my left, it's negative infinity x value. Right, it's positive infinity x value. It's pointing down on the left, so it's going to negative infinity. It's pointing down on the right, so it's also going to negative infinity. Then you just put your infinities accordingly. Last one is x. So this is my left, which is negative infinity. This is my right, which is positive infinity. It's pointing up towards positive infinity. This one's pointing down towards negative infinity. So as x goes to positive infinity, so my right dot, the arrow is pointing down to negative infinity. As x goes to negative infinity, so my left, y goes to positive infinity. So again, that's in short the key features, just a quick highlight. In the next video, I actually go through a couple examples.